Hi guys, this is Mrs. Gensler, and in this video we're going to talk about forces. Alright, so we made this foldable in class. Unfortunately I can't zoom out on it, so we're gonna look at these things together though. We're going to talk about it here. If you need to stop and write something down, then you'll have to pause the video. We're going to talk first about field forces. Field forces act at a distance. That means you don't have to be touching in order for it to work. These are also called fundamental forces because all of these forces come down to one of these in some weird way or another, which we probably won't ever talk about, and that's fine. But these are the field forces, okay? Our first force is called gravity. The force of gravity is given the symbol, and it's right here, Fg. On Earth, gravity points down, and it's always between two masses. So anything that has mass has gravity. I have gravity, you have gravity. Even though you may not be in the same room as me right now watching this video, we're still pulling on each other. It's just really small because Earth is huge and nobody notices that, okay? Anything that has mass has gravity. So gravity is our first of our field forces. The next one is the electromagnetic force. We use FEM or FE if we're just talking about electric, or FM if we're just talking about magnetic. And electric forces and magnetic forces turns out go together because they both depend on electrons. The electron itself has a charge, and those forces between the charges are called electric forces. If they're the same charge, they repel each other, and if they're opposite charges, they attract each other. But it has to do with the charge on the electron. The magnetic force is between any two poles of a magnet, and a magnet has a pole because electrons are constantly spinning. If they all spin in a similar manner, then the object is a magnet. Therefore, they go together. That's why they're stuck together. The electrons are for both. Now, our last of these field forces is called the strong nuclear and weak nuclear force. We would abbreviate them as F weak and F strong. We are not going to be using them in any force diagram you ever draw because they are inside atoms. The weak nuclear force holds together the pieces of a proton and a neutron. It turns out a proton and a neutron can be separated into smaller pieces called quarks, and the weak nuclear force helps to hold those together. The strong nuclear force is responsible for holding protons and neutrons together in an atom. Remember, protons, they're positive. They don't like each other. They don't want to stick together, so it's that strong nuclear force that holds them together instead. All right, that's our field forces. They're also called fundamental forces. They don't have to be touching. So those three are field forces. All right. Over here we have our contact forces. We'll first talk about it here. Contact forces are called contact forces because it requires contact. If the objects are not touching, then they can't be applying a contact force. So these forces require something to be touching. The first one I'm going to talk about is friction. Friction, we use F with a little f for friction. Sometimes just a little f is fine. Friction happens when objects are touching. The friction resists the motion, and it always points in the opposite direction of motion, or the way that it would go if it was moving. So friction is that opposing force. Okay, it always opposes. Force, air resistance, and water resistance, those are another type of friction. They're a type of friction. Air resistance and water resistance. You get air resistance when you're trying to move through air, and you get water resistance when you're trying to move through water, which if you've ever tried to run in a swimming pool, you know is pretty difficult. These are resistive forces, and they depend on how fast you're going. Any old friction when just sliding across the floor doesn't matter how fast you're going, but air resistance and water resistance does. Now there's this other force that people get mixed up with air and water resistance called the buoyant force. The buoyant force is FB. Buoyant forces are support objects when they're in a fluid. And by fluid, we mean air or water, okay? Helium balloons float in air. You float in water. That floating is a result of the buoyant force holding something up, okay? We talked about friction. Tension and elastic are similar forces. We use FT for tension. Tension is when you're pushing or pulling an object with a rope, a string, or a chain. You have to have some sort of cable between you or whatever's applying the force and the object being pulled in order for us to call it tension. If that thing is stretchy, like a spring or a rubber band, we call it the elastic force instead. Elastic forces are forces that try to get things back to normal also. Our last difficult one is called the normal force. We use Fn for, whoops, can't see it. We use Fn for normal force, and the normal force is the support from a surface. Right now, this table is holding up my hands, and so that's a normal force on my hands. If you think about it, you're probably sitting right now. Can you feel the thing you're sitting on holding you up? That's a normal force, okay? It's a support force. Normal force, support force. If it helps you to think about it as a support force, then go with that. They are always perpendicular to the surface, so it doesn't matter how the surface is oriented, the normal force is always perpendicular, okay? Now, any force that is not one of these others, okay, so these are all the forces that have names. If it's not, then we just call it a push or a pull, and you would write F push or F pull or F, Barbie or table, or something else like that, so that you would be able to identify what is causing the force. But any force that's not one of the other ones is going to be just a plain old push or a pull. So those are your types of forces there. Now remember, forces cause things to change what they're doing. They change what they're doing. So if an object is changing what it's doing, then you can know that there's a force there, okay? I hope that helps. Thanks for watching. Remember, you can always go back and watch this again if you missed anything. Thanks for watching.